Good afternoon, ladies and gentlemen. Welcome to Techgig webinar series. Our topic for today's discussion is around Iterator, a powerful but underappreciated pattern. And we have with us today Mr. Nitin Bhire. He is the Chief Software Officer at Geometric Global. A thinking craftsman, generalist by choice, Nitin believes in learning fundamentals rather than memorizing formulas. Worked on performance and algorithm-intensive projects, worked on multiple platforms, technologies, geometry kernels. He loves to teach and mentor as well. Experienced and hands-on teacher of software design, architecture, design patterns, design principles, etc. Some of the key discussion points from today's webinar would be Nitin would be talking about typical examples of iterators in common use, kind of problems that can be elegantly solved with iterators, when to use custom iterators and how to write custom iterators in C++, and much more, of course. Before opening up the session, this is a quick reminder for all the attendees. We will be taking questions during the last 15 or 20 minutes of today's session. However, feel free to start sending in questions from about 3:30 p.m. onwards. In between, if there is any connectivity issue, any audio drop, please feel free to inform the moderator on the chat window. Without any further delay, now I hand over the session to Nitin. Nitin, over to you.
Good morning, good afternoon, guys. Today's topic, as I said, is Iterator. I always like Iterator, but before going into this topic, I wanted to tell you a small story about Iterator. I was working on a project, and there was a junior guy in my team, and one day I suddenly saw him talking to some of his peers. And he was telling them, oh, what are you doing? And they were discussing what kind of work they are doing. And this guy says, oh, I'm writing an iterator. Some few days afterwards, same thing happened. And again he says, oh, I'm writing an iterator. Pretty soon my team came to know as the iterator team. Partly because many times somebody asked us what you are doing, we used to say, oh, we are writing a different iterator. Now that's happened around 10 years back. And recently when I was talking to some other developers, my peers and juniors, I realized that not many have really thought of custom iterators or how to write custom iterators and what exactly is the power of iterator. And today I thought it's a nice, good way to introduce everybody, or rather reintroduce everybody to my favorite design pattern, that is the iterator. So let's start with what is an iterator and what problem does it solve. So these are two definitions of iterator from Wikipedia. It says in object-oriented computer programming, iterator is an object that enables a programmer to traverse a container or a collection. Or in object-oriented programming, iterator pattern is a design pattern in which an iterator is used to traverse a container and to access the container's element. Nice definition, but it doesn't really tell us much about how to use the iterator and what is its power. So let's see some more information. As defined in Gang of 4 book of design pattern, the iterator pattern is defined as a structural pattern. And the essence of iterator, as defined in the GoF book, is it provides a way to access the elements of an aggregate or a collection object sequentially without exposing its underlying representation. In a sense, it says that it allows you to access a list or a vector or a hash table or a set in almost similar way without really worrying of what is the underlying data structure. So iterator pattern decouples algorithms from containers. So you can write, say, search pattern or find if kind of algorithm without really worrying of are you finding things in list, or are you finding things in vector? There are obviously some benefits of decoupling algorithm from collection. Once you define a common interface to access the elements of a collection, then you can use algorithms. You can write algorithms using this common iterator interface. This allows us to change the internal implementation of collection and with absolutely no change in the algorithm implementation. So I can write a find algorithm or a search algorithm or a quick sort algorithm in exactly same way on vector or list or hash table. It also allows us to add new algorithms, and if we define them on iterator, it will work on all existing collections. This is the pattern that is followed in standard template library, which provides a set of algorithms which work on multiple collection types with a single common iterator interface. So algorithms, you see the algorithms header file of STL, you will find it talks only about iterator. It doesn't really care about it's an iterator of a map or iterator of a vector or iterator of a list. If I want to define the interface for the iterator, if I want to use different algorithms, then iterator has to have a common interface. What are the essential operations, functions that an iterator interface needs to have? Actually, there are only really two, and maybe with some optional elements, 4 functions which you need to define to use an iterator. First function is current element, which returns the referencing one particular current element in the object collection. Next, calculates the next element that it should point to in the collection. Reset, it's again an optional thing which resets the current element to the start of the collection. And has next or isn't is another optional element which says if there are any elements left. So with those 4 functions, you can write practically any iterator. So this is a kind of pseudo code to give you an idea about how a simple loop.
Nitin, please let me know if you want to launch the first, if you want me to launch the first poll question now.
Yeah.
All right, I'll launch it now then.
So this is a simple example on how to loop with the iterator. First shows how do you typically loop with the index I equal 0 or I less than size something I plus kind of iterator. And similar iterator, how will you write with the iterator? Similar for loop with the iterator. So you are doing initializing the iterator, then always checking if the iterator is end is true. If yes, then you will quit. If not, then calculate the next element in the iterator, and then inside the for loop, use the current element in the iterator.
Okay, Nitin, we have the answers.
Okay.
For the question, have you used iterators in your project? Around 70% voted yes and 30% said no.
Okay. Okay. So let's look at some iterator implementations. How do you implement iterators in various programming languages? Of course, we cannot go deep into iterator implementations of various programming languages, but here is just a quick summary of iterators in different implementations in different languages and some pros and cons. So once you think of iterator as an object that allows iterator to have its own state that is different than the collection. So iterator can keep its own pointer to the current element. It can keep its own additional state, any additional state it needs. Because the iteration state is different than the collection, you can run multiple iterator objects on the same collection. Typically, most of the cases, if the collection changes midway while the iteration is in progress, usually existing iterators become invalid. In case of C#, you will get an exception that the collection object is changed while iteration is in progress. In practice, iterator and its collections are usually tightly coupled. So in case of C++, you have functions like vector.begin, which returns an iterator on the vector. And in a sense, then the vector iterator knows how to instantiate it, use its collection knows how to instantiate its iterator. So they are tightly coupled. Here are some examples of iterator implementations in different languages. In C++, STL containers are all define their iterators, and STL algorithms are defined in terms of iterators only. C# defines IEnumerable and IEnumerator interfaces, which are used to define iterators on C# collections. JDK defines iterator interfaces, and each collection implements their own iterators. SQL Cursor of a SQL query is in a sense an iterator. It gives you next row in the result set. So far we looked at all what is iterator, what are the basic concepts, and what basic functions are required to implement an iterator. Let's look at of the power of the iterators. When I say iterators are powerful, what I mean by that?
Okay, Nitin, I'm now posting the second poll question.
So first first important example of power of iterator is Linq, the language integrated query that Microsoft introduced in .NET framework, which adds the data querying capabilities to .NET language. So this is what MSD and documentation says about Linq queries. In Visual Studio, you can write Linq queries in Visual Basic or in C# with SQL Server databases, XML documents, ADO.NET databases, and any collection of objects that support IEnumerable and generic IEnumerable interfaces.
The poll results, they're here. For the question, have you implemented a custom iterator? 15% said regularly in my projects, 36% said rarely, and 53% said never.
Okay. So this poll results, as it says, that 50% of audience says that they have not implemented the custom iterator at all in their project. That in a sense tells you how rare the customer iterators are. We're talking about Linq. As I say, essentially power of Linq is because of the power of iterators. The IEnumerable interface that you can run Linq queries only on IEnumerable interface tells you a lot about the power of iterator. So here is another example of an iterator with a if check. So I'm just checking, iterating over a list of integers and finding out integers which are divisible by 3. So I'm looking at I 0 to 100, and then for each I am checking if it is divisible by 3. If it is, I'm doing a print. So this simple for loop essentially has 3 responsibilities. One is looping, other is filtering, and then third is printing the results. Now I move that into an iterator. Now it has a iter.reset. It checks if there is a next element. Then it keeps on calling move next. The iterator move next function is overloaded in such a way that if there are any numbers which are not divisible by 3, it just skips those numbers, and it.current is always divisible by 3. So now the loop has only two responsibilities. One is looping and other is printing the result. Responsibility of filtering is now moved to an iterator. And just by changing my iterator implementation, I can use the same for loop to print integers divisible by 3, maybe all prime numbers, maybe anything else. That gives me tremendous amount of flexibility in terms of how I want to calculate the next element in the collection. Here is another example of if check, and now I am comparing that with a Linq query, where I am doing a IEnumerable range between 1 to 100, and there is a where clause added which returns numbers only which are divisible by 3. Now the simple again, the filtering moves to where clause, while the for loop is just about iteration and print function. Just to give you one more example of power of Linq, here are the Linq provider implementations. So you will find Linq provider implementations for every kind of things. There are Linq provider implementations for Amazon databases, Linq for Active Directory, Linq for Excel, Linq for searching on the Google, Linq for querying emails using IMAP, Linq for LDAP, Linq for MyLucent, Lucent for doing the Lucent search, Linq for SharePoint, Linq for web queries, WMI, any kind of thing where you use a if and a for loop and a filter kind of queries, you can use Linq. So let's talk about various ways by which iterators get these powers. The first is iterators themselves can act as filters or views. You have a database view where there's a big table and the view can only show part of that table, or it may be able to combine multiple tables and create a different view. So you can think of iterator as a kind of view, where instead of returning all elements of a collection, it can filter and return a partial list. The filtering happens as needed, and you don't need to create any intermediate collections of filter results. Sometimes where the creation of this collection is costly, iterators can give you a nice compromise between memory and performance. Once your iterator interface is defined, you can write different implementations of iterators which can provide greatly different filtering criteria. The way we saw Linq providers, different kinds of providers are written with a very similar interface and on which you can write all kinds of Linq queries. Hence, you write the algorithm with a iterator. The same algorithm can work with a normal collection, or it can also work with a filter collection, or it can work with the combinations. Another reason behind iterators power is iterators can be polymorphic. What do I mean by polymorphic? I can define a base iterator class which defines all these reset, move, next as virtual functions, and then I can write all my algorithms using this base class iterator pointer or base class iterator references. So the same algorithm will work with any derived class iterator. This is the way I can use the same existing functions with different types of iterators. Next place where iterators gain power is you can combine iterators to give new iterators. So iterators are kind of composable. So you can combine, say, I can write a custom iterator which takes two other iterators as input. And first it iterates over one iterator, and once that is finished, it will iterate over second iterator. Or I can write a iterator which takes a collection of iterators and goes over it one by one. So this kind of chaining of iterators is possible. Now, if you know Python is a module called Iter-tools or iterator tools. This model is just about combining iterators in various ways. So the one liner below, which can say some IMAP operator multiply. So IMAP function takes multiple iterators and calls multiply function, which takes one element of vector 1, other element of vector 2, multiplies them, and returns an iterator of all those multiplications. Some function takes that iterator and keeps on summing all the elements and returns one final value, which in a way is the vector multiplication of, or a dot product of two mathematical vectors. And you can see how it's almost a one-liner. Most importantly, iterator need not always work with a real collection like a vector or a hash table. We can write iterators which work with collection-like objects. What do I mean by collection-like object? Think of STL iStream. It reads one character at a time. So we can think of iStream as collection of characters or collection of words. So if I split iStream as collection of words, then I can write a word iterator which extract one word at a time from iStream. And then I can process that one word in some various ways. I can also write an iterator which reads from a text file and returns only unique words. So if I have a for loop which works on these kind of iterators and dumps all those words, just by changing the iterator, I can dump the entire text file, or I can dump just unique words in that file. This is another example of how iterator works with collection-like objects is how Linq works with databases or XML files or even Google search queries. We already talked about extracting unique words from a text file. So you can create an iterator which has its own state, which keeps track of words it has already seen. And if the word is already seen, it will ignore that word and will not return it. So just by changing this, we can easily write a unique word iterator out of a text file. Similarly, if you see the C++ standard library or Boost library, you will find a directory iterator which returns all the files in a directory. The first example that we talked about at the start of the session was about laser cutting toolpath generation. So in one of the projects that I worked on, this was long time back, about 10 years back, the problem was to generate a toolpath for laser cutting of sheet metal parts. And the toolpath generation had different strategies based on different parameters, part selection logic, etc. Now to implement this different strategies, a naive implementation will require first writing complicated loops for different strategies. Then you have to pass various parameters as function parameters. Because they are written as two different loops, combining strategies that partially I will use this strategy, but for second part I will use different strategy, was nearly impossible. And because of all these for loops, it will create a lot of duplicate boilerplate code. And anytime I want to implement a new strategy, it's a mess. So we thought a lot about it, and then we came up with an approach. We defined a base class called toolpath iterator. The next function in the toolpath iterator generated the next laser cutting position. So every toolpath creation strategy is implemented as a derived class of this iterator. Now we could also implement iterators which derived from this base class, but internally they use some other toolpath iterators. That is a way you can combine strategies of, okay, partially use strategy 1, partially use strategy 2 kind of iterators. Then we wrote a factory method. We instantiated necessary toolpath and returned it as a base class pointer. So it took a name of the strategy and returned the base class toolpath iterator. Only factory method knew all the concrete iterator types. Everywhere else in our code, only the base class toolpath iterator was used. So now, anytime we want to add a new strategy, It was very simple. Add a new derived class from toolpath iterator, change the factory method to add the new instantiation of the new class. Done. A new method is supported in the existing toolpath generation. Everything else just worked. And it gave us tremendous amount of flexibility in terms of writing that code. Our customer used it for something like 10 years and he was getting some 1 million sheet metal parts on that every year. So why don't I see many iterators, or why when we asked in poll question only 50%, more than 50% said that they have never written a custom iterator? Why they're so underappreciated? My feeling is probably because it's kind of very simple concept, and developers have difficulty in believing that such a simple concept can have so much power. Of course, that's just my feeling. I'll really love to hear what others are saying. Another reason, my opinion, is a lot of other developers have difficulty in thinking, traversing or iteration as a separate object or responsibility.
So we have the result for the last poll question. The question was, do you think a custom iterator will be useful in your current project? Around 85% said yes and 15% said no.
Okay. So why iterators are underappreciated then? As I said, one is probably because people think that they are too simple. Other reasons could be because developers have difficulty in thinking in terms of traversal or iteration as a separate responsibility than maintaining the collection of objects. Maybe they have difficulty in thinking iterator as interface with multiple possible implementations. Or maybe it's just because iterator requires writing a new class, and because it requires some additional code, people think that just writing a loop is much more easier than writing iterator. So what do you think? What do you think of why iterators are so underappreciated?
Okay, our last poll question. Why do you think iterators are underappreciated? The poll is open now.
So what do you think could be the reason?
We are still getting responses. I'll just keep it open for maybe another couple of seconds and share the answers with the attendees. Okay, we have the answers. Why do you think iterators are underappreciated? And around 46% replied difficulty in thinking traversal iteration as separate. 43% said difficulty in thinking iterator as interface. Around 30% said writing an iterator requires defining a new class or function, and 10% said something else.
Okay. So I was seems to be kind of right. It's good that people don't think writing an iterator requires more work, so that's why I'm not writing iterator. That's great. Okay, let's go to our next step. So why thinking in terms of traversal iteration separate object? Why it is difficult? Now these are just my thoughts. Maybe developers are used thinking in loops which work on indices. For them, maybe I++ is conceptually easier than it.next or iterator.next. In fact, when I do code reviews, I see many examples of iterating over C++ vectors or even C# list using indexes like vector into bracket I rather than using vector.begin. Or even in C# for loop instead of a for each loop. So maybe that's why creating separate class or object to keep track of current element and a separate function for moving to next element is maybe a slightly difficult conceptual leap. But people who do make those leaps, you will find that your subsequent design changes significantly and has a lot more power. Another reason is say iterator as an interface with multiple possible implementation. Since it's a separate class objects, we can really create a separate interfaces. Just you have to get around the mind block that the iterator always has to be a concrete class. You have to think in terms of iterator as an interface, and then a lot of things fall in place. You can pass different iterators implementations and get different behavior. A simple example is if you want to traverse a tree. There are 3 different traversal algorithms: pre-order, post-order, and in-order. Now, rather than implementing all of them as part of the tree interface or a tree class, you can write 3 different tree iterators. There can be a base tree iterator, then you have pre-order iterator, post-order iterator, and in-order iterator. You can also add filtering if you want. The key is to start thinking in terms of one iterator interface and multiple iterator implementations, or hierarchy of iterator implementations. Once you make that conceptual leap, again you get a huge power in your hand. One problem: writing an iterator requires defining new class. This was true for languages like Java and C++. It required additional code, a lot of times additional separate file to implement that iterator. So it's kind of additional burden, and a lot of developers maybe could not visualize what benefit they are going to get with all this additional burden. Interestingly, this thing is changing with the coroutine implementations, with language keywords like yield or yield return being introduced in C# and Python. So here is an example of yield return in C#. The idea is to create an iterator without creating a new class. So here is an example of creating an IEnumerable. Again, our original example, divisible by 3. So now I'm creating a for loop and I %3, and then you will find a call called yield return I. Now coroutines is a slightly different concept than a function call, because every time this function gets called, first time it's called, it will come to yield return and return 0. Next time it comes here for this call, the execution will start immediately after the yield return call. So it takes some time to get around our standard definition of function and get into the concept of coroutine. But it makes a lot of things more interesting. Here are some tips for taking the benefit or best use of iterators, even if you don't want to write your own iterator. First, is use iterators instead of indexing. Avoid I++ indexing kind of loops. Partly or in general, loops with iterators are more efficient than the index-based loops. For example, if this kind of C++ code, for getting the ith element from a pointer, it requires that you calculate the size of the ith plus 1th element and add it into the start position pointer and then dereference the pointer. That has lot of extra computations that you need to do. You need to do extra multiplication, addition, dereferencing. While getting the next element from the current element is, if you already have the pointer to the current element, you just increment pointer and dereference. Now, if you are writing some for loops which are going to run millions of times, you will find significant differences with loops with indexes and loops with iterators. And long time back, I did a simple experiment of writing a matrix multiplication with indexes and matrix multiplication with pointers, or pointer plus kind of thing, iterator based matrix multiplication. And the multiplication time was like, difference was almost 100 times that huge. So wherever possible, prefer iterator based loops rather than or for each kind of loops rather than index based loops. This is specifically tip for C# and Java programmers. Never directly return a member collection from a class. It violates encapsulation. More importantly, you have no control if somebody just clears that list outside of class. Convert it into enumerable and return the enumerable outside, never as a list outside. So users of class XYZ can access the elements of the list, but they can access it in a very controlled way and not uncontrolled way, and a very limited functionality of that list is available outside. So users of XYZ cannot suddenly insert something in that list. That gives you a lot of control, and it just eliminates a huge class of errors from your code. Anytime you see a loop, for loop or while loop, and immediately after that a if condition, or you find a loop with very similar content at inside the loop at multiple places, think if you can convert it into an iterator. You can extract the similarities for loop and an if condition inside an iterator. Sometimes you have to create a base iterator, and with different move next implementations, you can easily extract the common part into the iterator, and only the modifications that you need go into the move next kind of functions. Or if you are using a C# or Python, you can always use the yield and the yield return keyword. I think I kind of mixed the one slide. Anyway, it gives you more explanation of why you should never directly return a member collection from a class. I already talked about that. In summary, as a developer, you need to change your thinking to think as traversal or iterator as a separate class object or responsibility. Think of iterator as an interface for which you can have multiple implementations, and think of different traversal strategies or algorithms can be implemented as different iterator implementations. Once you change your thinking, you will find many more uses of iterator. You will find that it tremendously simplifies your code. You will find that iterators make your code less bug-prone, more stable, more easier to enhance and maintain. So let me see the questions.
Yes, Nitin, I have already posted a couple of questions. You will find them in the questions window.
Yeah. So the first question is, can you define the iterator on SQL? This is from R.K. Kabilan. Uh, SQL Cursor is conceptually a iterator. What do you mean? Typically, you run a select query, and for the select query, you get a cursor object. From that cursor object, you extract one row of the select query. Once that is done, then you can just say, okay, go to the next row, and the cursor will take you to the next row. That is essentially what the cursor does. That's why I said the iterator or the SQL cursor is kind of iterator. I'm not sure if that answers your question, Kabilan, but maybe I misrepresented it. What are the advantages of using custom iterator, which will have over default iterator? Custom iterator requires more memory, right? Will it going to store in somewhere? Will it require custom iterator? Will it require more memory? Not necessarily, because a lot of times what you end up doing is you iterate over a collection, you run some filtering logic on it, and then you create a new collection. So the new collection is anyway going to take some memory. Instead of that, if you put the next logic into the iterator, then the things are more simpler. And does it require more memory? Yes, maybe slightly. It's equivalent to, you will probably have to hold iterator to an existing collection or the default JDK iterator inside your iterator. And I think that's all. I have not really seen iterators taking that much more memory. In fact, most of the cases when I converted code to iterator, the memory consumption actually reduced. What are the steps to write the iterator? As I said, it slightly changes from language to language, but mostly you need a way to calculate next element in the iterator. So in case of C++, you will have to override operator ++. In case of C#, you have to override monext function. And of course, you always need a current element function, or in case of C++, this is operator star. How to write a custom iterator and how to use it in C#. The best way of writing custom iterator in C# is to use yield return keyword. You just have to write a for loop or a function which uses yield return and returns IEnumerable. Normally, you use enumerable with a for each or with a Linq query in case of C#. The question by Manoj Gaiwal, this is very interesting one. In a single project, there could be number of loop plus if. Is it feasible to create separate class for each iterator and compiler again maintain its class references, etc.? Now, if you are using about C++ project, probably difficult, but C#, you don't need to create a separate class. You just need to write a function. And yes, it is worth creating a separate class only if you use similar kind of loop if at multiple places. Otherwise, yes, I can see it's a word. If your every loop is in a different, then there is no point creating that many classes in C++. Is iterator faster than traditional ways of getting the next element like operator ++? If you are using indices, then iterators are usually faster than indices. Otherwise, they are probably going to be a near similar performance. This was from Akhilesh Kumar. one question regarding iterator design, can we use strategy pattern to change the MoveNext logic instead of having to multiple sub-iterator classes? You can, but in my experience that makes your MoveNext function more complicated, and then you have to configure your iterator with a different strategy every time. I don't know, probably multiple sub-iterator classes and multiple strategy pattern implementations. Probably you will need probably have to write the same number of classes or same number of lines of code. But personally, I find it easier to create different sub-iterator classes. Now, strategy pattern has its advantages. I am not saying that everywhere you use strategy pattern convert it to iterator. What are the differences between IEnumerable and IEnumerator? Actually, IEnumerable has a function called getEnumerator, and the enumerator is the one which actually implements the MoveNext and current element and all this iterator semantic. Can we replace normal loops with iterators? Yes, most of the time you can. And a lot of times it gives you a lot more flexibility. This is from Lavanya Guma. I hope that answers the question. How bad would the impact on performance be if iterators are used too frequently? From Geeta K. It's hard to answer this question without any kind of background on how the iterators are written. But in my experience, I find if you're using iterators, it's much more easier to fix any performance problems rather than for loops. A lot of times when the key thing which can take time is your MoveNext function. If the same kind of for loop is spread over 10 places, then fixing all those 10 places is difficult. However, if I have a MoveNext function at one place and I fix the computation inside MoveNext and change the strategy of MoveNext, then maybe I'll get the same kind of performance improvement at all 10 places. So yes, I have done a lot of performance improvement in cases like in some cases from 30 minutes to 6 seconds and like that. And in every project I used iterators and then tweaked the iterators for better performance. Want more explanation on toolpath iterator? Okay, what can I say?
Nitin, there is some disturbance in the line.
Yeah, I don't know why.
Yeah, this is better now.
Yeah. So toolpath iterator, basically there was no collection behind toolpath iterator. It's a kind of iterator which looked at the set of sheet metal parts, their boundaries, and decided how to cut those. And it returned a new cutting path point at every operator plus instantiate. And how to calculate the next point in the toolpath is the logic inside the MoveNext function. I know it's kind of confusing explanation, and I'm not able to give you all the details without some kind of code example. So I'm really sorry about that. Did I answer most of the questions? Or? Okay. what is yield in C sharp. Yield is a new keyword in C sharp, yield return or yield break, which is used in writing coroutines. And in a way, it allows you to create functions which return IEnumerable. So instead of implementing iterator as a new class, you can implement the entire iterator functionality inside a single function. That's kind of simplistic explanation. If you search for yield in C++, you will find many examples on Google that will tell you more ideas of what it is. Prashant, I'll suggest that just try for yield in C# and or enumerable and yield, and you will get a lot more ideas and examples on how to use a yield keyword, which has good performance for each or for loop using list iterator. Chetan, both of them will have really same performance because for each internally uses the list iterator. So there won't be any big performance difference in for loop using list iterator or just with for each. The difference is more on syntactic side, and a for each thing is slightly easier to read. That's it. Runtime performance, there won't be big difference. Will implementing iterator result in increasing binary executable size? Akhilesh Kumar, maybe somewhat. Depends on how you are using iterator, because but not much, because see, anyway you are going to write a for and an if check. Now the same code is going to go inside your iterator class. So the code size will not change much, but instead of code sitting in for loops in various C++ file, it will go inside a single C++ class. So maybe slight increase in binary size. I think I have answered most of the questions.
One or two questions are still there. There's a question from Vinod Ingle. He's asking, is it possible to store? Yeah.
Yeah. Is it from Vinod? It says, is it possible to store SQL table data in enumerable var? If yes, which one useful to store data in data table object or enumerable var? If you want, you can treat SQL Cursor as enumerable, but the problem with enumerable or SQL table as enumerable is once your query is done, you cannot go back and kind of, if you redo the query, it will again hit the database. Okay, so if you want to reuse that data, store it in SQL table. If you are going to use it only once and going to generate the ASP.NET table, use IEnumerable. You can use both, but once you get the SQL data, the key is how many times you want to reuse that data. If you want to use it only once, IEnumerable gives you flexible code. If you want to make a query and then reuse it at multiple places, then first put it into the data table and then run a IEnumerable on the data table. In C#, can we implement iterator in dictionary collection? Yes. You just have to write a custom function with yield. This is for Sudesh Nabua. Iterator is more useful in non-linear data structure as compared to linear data structure. Please explain. Ritesh Kumar. Ritesh, I do not completely understand your question. If you can give me some more details, I'll be able to answer this.
Nitin, while we wait for more questions.
What do you mean by linear and non-linear data structures?
Yeah, please go ahead.
Hello.
Yes, Nitin, you can take that question, that last question.
Yeah, but the question is, iterator is more useful in non-linear data structures as compared to linear data structures. This is a question from Ritesh Kumar. I'm not sure how to answer that. I'm not sure what exactly Ritesh means by non-linear data structures. So Ritesh, can you just put some more elaboration on that question?
Yeah, I'm sure he has received that note from you. So while we wait for Ritesh to get back to us, um, I'm pretty sure there are people today in this session who would want to know the kind of skills which are required for these kind of profiles, and the do's and don'ts in general, which you very briefly touched upon. But if you could answer some of the questions which have been forwarded to your chat window. Please refer to those questions, Nitin.
Mm, Yeah, I'm not sure which one. Not sure what you mean by the skills required for this kind of profile. Uh, in my experience, I have used iterators in web development, in graphics applications, in computational geometry. It's a concept that you can apply in any programming language and in practically in any domain. You just have to get get out of the mindset that looping means I take an index and I do 0, 1, 2, 3 and count like that. You have to think that looping means I start with one element and with some computation I go to next element. What that computation can be is different for different collections and different algorithms. Once you get into that mindset, then things are easier. So the key thing is to change your mindset and understand what the design pattern means. Skills, any language and technology are okay. Iterator as a concept is applicable in multiple languages and multiple technologies. There's one more question from Sharad Agarwal on, do you think main use of iterators is just alternative to complex loops? Kind of. Most of the cases, for simple things also you can use iterators, but complex loops, they're really shy. Converting the iterator complex loop for if conditions into iterator really simplifies your code.
I can see one or two more questions. We have around 2 minutes. Okay, Ritesh, he has sent the revised version of his question. I'm just assigning the question to you.
Okay.
I'm still not sure if the question, if he has formatted the question correctly, but I have any which was assigned it to you. I hope you can see it in your questions window.
Is this, I think iterator is good programming practices for linked list tags, queues, trees as compared to linear loop and array. Do you mean linear loop by indexes and arrays? Maybe yes. If you have a say array of integers or some standard C++ array, then you can use it with indexes. If that's what you mean by linear loops. But in case of C++, actually in my experience, pointer plus plus loop iterations is usually faster and better performance than index-based loops. So I don't know. It's kind of hard to answer. without much details of. Maybe I am not able to completely understand the question.
Yeah, maybe Ritesh, if you could also take these questions offline with Nitin, as we are running out of time. And probably with this, we come to the end of today's session, and I would like to thank Nitin for giving such an insightful presentation and taking up so many questions. Though there are still more questions pouring from our attendees, and I would like to request all the attendees to share the questions with Nitin offline, or you can also send the queries directly to us. The recording version of today's webinar will be live, will be available on techgig.com by tomorrow afternoon. So those who joined in a little later or missed out some part of the session today can always follow up and find the session on techgig.com. Once again, thank you so much, Nitin, for taking time out today, and we would love to working with you again in near future.
Thank you all the participants and guys who asked questions. I hope I have answered to your satisfaction. If not, feel free to write a mail to me and I will reply. Thanks again.
Thank you, Nitin. Thank you, everyone.